Stress relaxation test. Stress relaxation is the absorbed decrease in stress. So it is the absorbed decrease in stress, and this decrease is a response to the strain generated. So as you can see in this graph, so a system is being strained. Let's say the material is initially like this, which is not going through any kind of strain, and at a later stage, because of an applied strain, so the material is elongating and then it reaches finally a constant strain. So after straining, so as we can see here, so there is no strain increases and then strain is kept constant. When we say there is strain, there has to be corresponding stress. So as you can see in an ideal elastic material as given in this graph, so as the strain is increasing, the stress is also increasing. Or when we are deforming a material and causing strain, deformation can be happening only when we are applying stress. So this deformation is caused because of applied stress. So the strain is generated because of stress and the material is deformed. For ideal elastic material, the stress is increasing and then the stress is kept constant or fixed. So for an ideal elastic material, it requires the same quantity of stress. And stress relaxation test is understanding the decrease in stress in response to strain generated, and in ideal elastic material there is no relaxation. The stress required, that is the stress required to maintain the fixed strain, is studied, and we can also see this is the strain that is caused by deformation. So this graph gives the strain that is generated due to the deformation, and this graph gives the stress corresponding to the strain or the deformation. By using this, we can understand how different types of materials behave when subjected to stress relaxation test, and this will be really helpful in classifying or understanding or identifying several materials. For example, differences between cheese. Let's study ideal viscous materials. So as you can see, this is the strain that has to be maintained, and as you can see, ideal viscous material never goes through a stress. It relaxes instantaneously. Instantaneous relaxation is noticed in ideal viscous materials. For ideal elastic materials, so as we already saw in the introduction, so to maintain the fixed strain, an equal or proportionate stress has to be applied. So the material is not relaxing. For viscoelastic materials, viscoelastic material at fixed strain is relaxing, and you can see viscoelastic solid is not going to zero, whereas viscoelastic liquid is relaxing to zero. And this sigma C is called the equilibrium stress required by viscoelastic solids. So generally, viscoelastic materials have solid component and liquid component, and liquid component relaxes very easily because of higher mobility of liquid, and because of that, liquid part of viscoelastic materials relaxes to zero and solid does not relax to zero, whereas an equilibrium stress is required to maintain the fixed strain.